Okay, now that we know what an ore is, how do ores form? And so our first method is going to be called magmatic deposits. So obviously we need a magma chamber for this. Now we learned when we were talking about igneous rocks that certain minerals will begin to crystallize at certain temperatures. So in this magma chamber, as it begins to cool off, certain minerals, especially the ones that contain sulfur, so your sulfide ores, are going to begin to crystallize. And as they crystallize, they're going to begin to fall down in the magma chamber because they're now heavier. So they're going to pile up at the bottom of the magma chamber. Then, as the magma chamber completely cools off, now you've got this igneous pluton, and then at the base of it, you're going to have these sulfide minerals, such as magnetite. Okay, another method is going to be hydrothermal deposits. And so what you're going to need here is a hot area, and you're also going to need water. So an ideal place will be a mid-ocean ridge. Another place might be somewhere that you've got geysers. So water from the ocean is going to percolate down into the crust, and then it's going to start to be heated up by the magma chamber, and then as it's heated up, it's going to start to dissolve away certain kinds of ores and minerals. And then as it begins to cool off, as it approaches the surface, it's going to start to precipitate those ores into veins. And so this is, for example, how we get gold deposits and copper deposits. Okay, another one is going to be called secondary enrichment, which is very similar to hydrothermal. So in this case, what's going to happen is the groundwater is going to dissolve a particular ore that it was already established. So the ore was already concentrated. The water is going to dissolve that ore. It's going to carry it somewhere else where conditions are different, and then under those conditions, those particular ores are going to come out of solution and are going to be precipitated. So an example of this would be azurite. Okay, then you've got MVT deposits. So in this case, you're going to have some kind of a sedimentary basin, and then it needs to be hot down here. So maybe there's a magma chamber. So let's say that it rains over here, and then as it rains, then groundwater is going to get in, and it's going to be following a crack or something, so that it's going to be getting closer and closer to this hot area. So the water's going to get hot, it's going to dissolve certain kinds of minerals and ores, and then on its way back up to the surface, it's going to start cooling off, and then it's going to start redepositing those ores. So an example of this would be how you get galena. Okay, another one is going to be called sedimentary deposits. An example of this would be banded iron formations. So roughly 2.2 billion years ago, the Earth was mostly ocean with a few continents, and various kinds of bacteria began to produce oxygen. So the first oxygen was being pumped into Earth's atmosphere. But as soon as it got into the atmosphere, it was dissolved into the oceans, and then it started to rust iron that was dissolved in the oceans. So then that rusted iron began to precipitate to the bottom of the ocean. So you have layer after layer after layer of rust that started to appear, and it was compressed together into sedimentary rock, which we call the banded iron formations. Well, today we mine that. So we mine this 2.2 billion year old ore, and then we smelt it, and then from that we get all of the iron that we're basically using today. Okay, then another thing is residual mineral deposits. So if you recall, when we talked about soil formation, we said that rainwater, when it percolates down through the ground, it can concentrate aluminum. So aluminum can be pulled out of the zone of leaching and eluviation, and then it's going to start to accumulate in the soil below that point. And so if we find these petrified soils, we can then remove all of that aluminum in the form of bauxite, and then that's where we get aluminum cans from. And then finally we got placer deposits. So one thing about gold is it's very, very dense, and so that means as it erodes out of an outcrop, it's not going to go very far. So it's going to roll down the hill, it's going to get into a river, but because it's so very dense, it's not going to travel very far from its source. And so this was the first way, really, that humans found gold, is in a river. And then they would follow the river back to its source and find the outcrop where the gold was coming from. So these are all different ways of making ores. Okay, we're going to take a break, and when we come back, we're going to talk about various kinds of ores and where they're found in the world.